So we're going to be looking at the Chapter 7 quiz for the upcoming 6th grade quiz. And this is going to be on the algebraic section of the topic. So a lot of this is dealing with variables and how to transform a word problem into an expression and a lot of that stuff. So it's kind of a weird quiz based on the previous ones we've done, but it can get done pretty easily. So the first one says write an algebraic expression that represents the situation. So what an algebraic expression is simply a collection of numbers and variables that are added, subtracted, multiplied, and divided together. So all you really need to do is read the problem and figure out what's my number, what's my variable, and what's my operation. And sometimes you might have more of one of each, but that's the main idea. What operations do I have? What variables do I have? What numbers do I have? And then put them together. So the first one here says the sum of y and 10. Well, sum means to add, so I'm going to add two things together. And what two things am I adding together? Well, it says right here, y, which is my variable, and 10, which is my number. So this is the algebraic expression of this statement. The sum of y and 10 is just simply y plus 10. That's all there is to it. So again, look for the operation, look for the variables, look for the numbers, and then put them together. The next one's a little bit trickier. A taxi company charges $2.50 plus 75 cents per mile. Write an expression to represent the cost for going m miles. So we have our variable right here, m. So m represents the miles. So unlike this one, I'm going to start with my variable, m. Now, I want to write an expression to represent the cost. So I want this expression to show me how much money I'm going to pay. Well, how do I figure out how much money I'm going to pay if I'm going to go m miles? Well, it says I pay 75 cents per mile, which means that for every mile I pay 75 cents. Now, this word per here can mean either division or multiplication. And in this case, it means multiplication because it means for every mile I pay this much money. So I'm going to multiply that 0.75 to my m because every time I have an m, I'm going to pay 0.75. So if I have 1, it's going to be 1 times 0.75. If I have 2 miles, it's going to be 2 times 0.75. If I have 10 miles, it'll be 10 times 0.75, and so on. So if you hear the word per, that's usually going to be either, like I said, division or multiplication. And in this case, and in most cases for normal word problems, it'll be multiplication. Now, this isn't all that I pay, though. I don't just pay the 75 cents per mile. I pay the 250 as well. So after I have this down here to get my total cost, I'm going to have to add to that $250 fee I had to start up. And then this is going to be my final expression. So my cost comes in two parts. The 250 I pay no matter what, and then the 75 cents per mile I pay after that. So it's just like number one here. It's still an addition expression, but you have to kind of read into the problem a little bit. And plus it has the word plus in here, so you know that you're probably going to have to add something in here because it says plus. Now the order of addition doesn't matter. So like for example, in this one I could have written 10 plus y. That's the exact same thing. So it works out both ways. But for number 2 there, the 0.75 has to go to the m because you're paying 75 cents per each mile for every mile. So it's a multiplication part there. The next ones are about evaluating. So in these, you want to get a single numerical answer. And all you need to do is just replace the variable with the number they give you and solve. So for example here, b plus 1 squared minus 10. Evaluate this when b is 5. So all that means is take out b and put in a 5. And then work the problem like normal. So order of operations says do parentheses first. So 5 plus 1, that's going to be 6. So 6 squared minus 10. 6 squared, that's going to be 36 minus 10, which is going to give you 26. So that is my final answer there. So all this is simply, again, take out the number, take out the variable, put in the number, and solve. And remember, you do parentheses first, then you do the exponent, and then you do the subtraction. So make sure you don't forget the PEMDAS order of operations. Here it says evaluate this when x is 7, so let's go ahead and rewrite it. And again, it's helpful to rewrite the entire problem without the variable by putting in the number. That way you know exactly how to take things. So PEMDAS says to do the parentheses first, so this comes first. So 10 minus 7 is also 3, squared divided by 9. 3 squared, because exponents is next, remember PE, so exponents is next. So 3 squared is 9 divided by 9. Then comes multiplication and division done left to right. So the MD part means multiply and divide as you see them left to right. So the first thing I see going from the left is 3 times 9, which is going to give me 27 divided by 9, which brings me back to 3. So that's my final answer there. So if you can do normal order operations, adding, subtracting, multiplying, dividing, this isn't any big deal. Just replace the variable with the number. If you have more than one variable, then replace them all with the same number. So if I had multiple x's in here, I'd replace all those x's with 7. Or if I had a x, y, and z, and I have x is 7, y is 5, and z is 10, I replace x with 7, y with 5, and z with 10. All you do is just simply rewrite the problem, erase the variables, and put in the correct numbers for them, and then work it like a normal math problem. The last bit is about combining like terms. So combining like terms is simply when you're going to put together your non-variables and put together your variable terms together as much as you can until you can't do it anymore. The golden rule for combining like terms is you cannot add and you cannot subtract two values that have different variables. So I cannot do this. 3 plus 5x equals 8x. I cannot do that. That is a no-no. That cannot happen. You cannot add a non-x to an x. They have to both have x's in order to go together. They have to both have y's to go together, or they have to both have no variables to go together. You cannot add a variable and a non-variable together like that. Now, what you can do is multiply. So I could do 3 times 2x is 6x. That is okay because multiplication doesn't care. Because this is basically saying if I have 3 sets of 2x's, what do I have? Well, 3 sets of 2x's is just 6x. So that's what you have. You have 6 x's. So multiplication is okay, addition and subtraction is not. Now, when you have something like this, it's kind of hard to simplify it because what's the first thing you do for order of operations is parentheses, right? Well, I can't do parentheses here because I can't do x minus 2. X minus 2 can't happen because, again, one is an x, one's a non-x. So what I do is something called distribution, which means that if you have parentheses and there's a number outside them, like this 3 here, and again, it can't be added or subtracted, it has to be plain outside the parentheses. What you can do is take that value and multiply it to both terms on the inside. And when you do that, the parentheses go away. So what's 3 times x? Well, 3 sets of x's is just 3 x's. 3 times 2 is minus 6. And then I just had the plus 5 still sticking around. So now I have my parentheses are gone. So this is kind of a way to sidestep the first step of order operations is distribution. So distribution is kind of like an outside operation that allows you to skirt around the first part of PEMDAS. That way you can get to the combining part. Now in this case, the negative 6 here, the minus 6, that doesn't have anything to go with. There's nothing to combine with the minus 6. So I'm just going to leave it as minus 6. But the 3x and the 5 I can put together because they both have an x. 3x and 5x when put together make 8x because they're both positive. So 3x's plus 5x's is 8x's. And then that's my final expression. So again, I'm not going to get a single number answer for this. I'm simply going to get a reduced expression. So instead of having this big thing here, I just have this thing right there. But again, you cannot combine an x and a non-x. So I could not do x minus 2x, or x minus 2 is like minus 2x. I cannot do that. I have to do distribution first, and then I have to combine my like terms. Now, they don't have to be together. Like here, 3x was in front, 5x was in back, but I could still add them together. But they both have to have an x with it in order to be put together. Same thing with the 6 here. I cannot do this inside the parentheses, so I have to go to distribution and multiply the outside number to both inside numbers. So 3 times 5x, 3 times 5 is just 15, so it'll be 15x. Plus 9 times 3 is 27. Then I bring down everything else, minus 3x, plus 2. Then I combine my x's first. So 15x minus 3x. So now, again, this is a minus 3x here, so make sure you say that to yourself. 15x minus 3x is 12x, not 18x. And 27 plus 2 is going to be 29. And we're going to put a big plus in the middle. If you don't know what to put in the middle, just default to a plus, because that's what it's going to be. Unless it was a negative number, and then it would be a minus, like we have here with the 6, because it had a minus in front of it. But other than that, it's just going to be a plus. And this would be our final expression. So your final expression is usually going to have an x and a number, or an x and a y and a number. So you're going to have only one of each variable. Like here, I have 2 variables. I have an x and an x. I have 2 of the same variable, and I have 2 non-variable numbers. Combining like terms means you get everything down to just one of each. One x, one non-x, one y, one z, one k if there were there, that sort of thing. So like I said, this quiz is a little bit different because it's dealing with combining terms and not necessarily getting a solution to an equation or anything like that. It's simply about rearranging and working with expressions and getting used to how variables kind of halt you in your process there and how to work with them and write them and all that. So that wraps this one up. Hope you enjoyed the video. Have a good day.